part that's under the radical, and it is obviously this right here, the b squared minus 4ac, which is under the radical for the quadratic formula. So go ahead and write the quadratic formula down. Okay, we did that last class. So today we're just going to concentrate on the b squared minus 4ac. There's an example on this side when you actually use the b squared minus 4ac, and keep in mind you don't use the radical with it when you're talking about the discriminant. It's just simply this part right here without the radical. So if I were to actually put in the values of b squared, which is -4, square it, minus 4 times 1 times 3, my final answer comes out to be +4. So the discriminant will let you know how many solutions you have. So if your discriminant comes out positive, in this case it did, okay, and you need to write that little statement down. If the discriminant is positive, that means you should be looking at the end when you do your quadratic formula, you should have 2 solutions. So the discriminant will tell you how many solutions you're going to have. And your options for solutions will be 1 solution, 2 solutions, or no solution at all. So if the number comes out positive, you have 2 solutions. So that's why when you all are doing the quadratic formula, I always tell you to do the discriminant piece first, because you're going to find out if it comes out negative, that means you do not have a solution, and then you do not need to continue using the quadratic formula. All right. So obviously write this down as your discriminant, b squared minus 4ac. Okay, that is the discriminant piece. Okay. And this is just showing you what 2 solutions would look like. So you can just basically sketch that. It looks like it's crossing the x-axis at 1 and 3. The vertex looks like it's at 2, -1, and just make a sketch. Okay. All right, so this is what you should have. If you want to fold it, it will look like this. So you just simply fold both of those pieces inward. All right, so here's example 2. So in example 2, same thing. We're going to do the discriminant piece first. And when you do the discriminant, the b squared minus 4ac, so you know this is your a term, this is your b term, this is your c term. Okay, when you substitute all those numbers in, your answer in this case comes out to be 0. So if your discriminant is 0, there is then 1 solution. So I'll give you a chance to write that down. All right, so if you have 1 solution, that means that your vertex is sitting right on the x-axis. Okay, so you can just go ahead and copy this table. I know you guys already know how to make a table because it was on your last quiz, so you can just go ahead and copy the table, plot the points, and make your graph. Okay, so I'll stop and give you a chance to do that. Down. So this would be an example of no solution because your discriminant is negative. So that means you would not have to continue using the quadratic formula to find them because you will not have any x-intercepts. And then I'm going to show you what a graph would look like. Okay, this is the graph of one where it is not touching the x-axis at all. You have no solutions. Okay, so go ahead and copy the table, plot the points. It's also showing you that vertical line for the axis of symmetry. Okay, so I'll pause this. All right, so when we're talking about projectile problems, just think about it. If you're diving off of a diving board, and let's just say, I'll just draw a little picture here. Okay, you dive, and then obviously you have to come down to the water at some point. So let's say that's the water. So when you actually land, I could ask you the question like, how long will it take you to, land in the water? And so you're looking at the x-intercept. So think of this like your x-axis where the water is. And if I say, okay, how long will it take you to land in the water? Okay, you're looking at when you hit right here, which is like your x-intercept. Okay, so the whole purpose of knowing the quadratic formula is so you can get those exact numbers or exact seconds, in this case, how long it would take you to hit the water. Or I could ask the question, how long will it take you to reach your highest point? So that means you're talking about this point up here. Okay, so we're going to just go through one example, and then after this, I'm going to give you some problems to look at based on the things that you're going to see in this particular foldable. Okay, so anything that's like projected, whether it's a ball, a rocket, will always follow that curve of a parabola. Okay, so let's start off with just the problem itself, and I'm going to actually go to where the answers are. So it says, what is the height of the stone? So it says, Mark throws a stone off a bridge into a river below. The stone's height above the water in feet. So h of x would be the same thing like y equals, depends on the time in seconds after throwing. X is modeled with this function. Okay, so that's almost like the time here. So a lot of times on your SOL test, you'll see like h of s, k of x, that is, I meant. So anything of x is like y equals. So it doesn't matter what variable they put here. If it has parentheses x, that means it's in function notation. So that's like your y equals. Most of the time, they will have these variables as a t for seconds. Okay, so we have x's right now, but most of the time you'll see a t. You will be given what the equation is, and then you're going to be asked some questions. So the first question here says, what is the height of the stone at the time it is thrown? Okay, so that means at the time it's thrown, you're looking for the y-intercept. And in this case, the y-intercept is your C number. So you need to know which number is the y-intercept. It's this number right here. That is your C term. Okay, so if it says, what is the height of the stone at the time it was thrown? Okay, then that's your C is 5. How many seconds after being thrown will the stone hit the water? So if you're looking at this graph here, notice that you have two x-intercepts, but you always go with the positive x-intercept. You never go with the negative because we can't have negative time. Okay, so you always are going to be going, so even if you graphed it and you saw, oh wow, there are two x-intercepts, which one do I use? You always use the positive, okay, because it doesn't even make sense in the real world to have negative time. We can't go back in time. So in this case, it will take 2.41 seconds. Now, how would you get the 2.41 seconds? Using the quadratic formula, because you can't read 2.41 from your graphing calculator. So that's where you're going to have to take your formula. And of course, this formula, you know how we separate it into two parts, will give you the negative answer and it will give you the positive answer. So again, we always take the positive answer. Okay, the next question, how high in the air does the stone reach? So that means you're up here. Okay, you're like at your vertex point. All right, because you know vertex is, in this case, will be a maximum point, the way that this curve is going. So that's going to be the y value to your vertex. Okay, how? So if it asks you how high in the air does it reach, then you are looking for the y coordinate to the vertex. So how do you get the x coordinate to the vertex? You do x equals the opposite of b over 2a. and then pair it up with the y, and that's the answer for part C. Okay. How long does it take for the stone to reach the highest point? Then that's the x coordinate to your vertex. Okay, so the x is how long it will take. Okay, and the y is how high in the air does it reach. So again, you're looking at your vertex points, and there's your vertex right there. Okay. All right. You might want to label the picture so you'll know, where these numbers are coming from. Okay, it'll be a good visual for you.